take x, y itself is given to you. Okay. How do we find the probability of interest? For example, probability that x is confined between the region A and B, y is confined between C and D. X is between A and B, y is between C and D. You are given this one, how do we find it? This is a very generic probability measure of a region. If you want to put minus infinity, then this becomes here minus infinity, it becomes fy, xy of b comma d. If you put these two as minus infinity. Okay? So this is a general one. How do we find this one? So if you look at the plane, xy plane, xy plane. So this is A, this is B, and so this is C, this is D. Okay. So I am looking for this region. Probability measure, the probability that of the random variables x and y together taking a value, any value in this shaded region is what we are looking for. But you know this joint CDF only. From that, how do we find it? Okay. For example, to find this area, what all I know is, I know the functions of this form, that is all the way from minus infinity to one value, all the way for x, similarly minus infinity to some value here, that thing I can do. That is, if minus infinity is lying here, all the way I can find up to this one. Let us look at this point. What is this point? If you look at everything which is below this line, and to the, if for me if it is right, this is left. To the left of this line. What is this quantity? Everything below this line and everything to the left of this line. What is this quantity in terms of the CDF? B comma D. Right? So it goes. So if I substitute B for x and D for x, everything below this is being given. So everything is there, but I want only this one. What I do? I will subtract this one. And also subtract this one. Because all these are not allowed. So how do I, subtracting this means, I have to evaluate at A comma D. A comma D, if I subtract everything will be gone. Similarly, if I subtract everything from this one, B comma C. So you have to be note the A and B corresponds to X. So B comma C. So I have removed from whole of this one, I have removed this part, I have removed this part. In doing so, I have removed this twice. I have to add it up once. Then only this will remain. So plus A comma C. This is how you can find from using joint CDF a probability of any given shared region. Well, now coming to the density function, joint density function. So U is given by h of x comma y, and V is g of x comma y. We will not get through CDF is right approach, easier approach. find CDF and then get the PDF, or if you want to work only with PDF, you are given fxy of x comma y given fuv of u comma v is being asked. That's what we are looking for. Well, if you are looking for this one, let's try to look at what we are talking about. Okay, this is the x and y plane. How do we interpret this? For example, if we have x and x plus dx, and this is y and this is y plus dy. See, this is a variable, this is a specific value. I cannot have different notations. So I hope you will be comfortable with this. This is a variable, but these are specific values. So the property of this shaded area is fxy of x comma y dx dy. This is the interpretation. But what you are doing is, we have two functions of two variables. U and v are two functions of two random variables x and y. So if in the u-v plane, if you look at so this lines can be traced here. What is this line? This is x is equal to, I should put it as a or something, x equal to this x, that is this line, x plus dx. These two will be curves. And x plus dx will be a curve which will be mostly parallel to it, slightly different from it. That's what we would expect. And similarly, v and v plus dv will be two curves like this. So I put u plus dv, and this is v plus dv. So u plus du. Okay. So suppose you know that this is the point x comma y, and if you plug in these two values x and y in these two functions, okay, you get u comma v, which is this u comma v, such that u is equal to g of x comma y and v is equal to h of x comma y. Okay, so I am looking at a strip of this kind, and this point at the center of it is some value 2, 3 or whatever it is, x comma y, and then I plug it in this one and find the corresponding u and v, and it goes to this point, and I construct a similar strip around this one. Okay, and so what I know is a point here is mapped to this point here. A point next to it will be mapped here, and so on. They are all mapped adjacently. Okay, so if I want to find the density of this one, it is proportional to this density here. But only thing is, this area is dx dy. This area is du dv. Okay, so they are related, and this relation is what we have to find out and preserve it. Then we might translate this property density. Then only it will be normalized. It is the same as this Jacobian that we have used previously. So to find that, what we have to do is, so how do we, given for example f u v of u comma v is being asked. So you have to find the pair of x comma y which will map to this u v. Okay, how do we find it? By solving this function. U is equal to g of x comma y and v is equal to h of x comma y. If you solve these functions, you may be able to invert it and get functions x is equal to phi of u comma v and y is equal to psi of u comma v. Okay. So we want the density of this function. Then if you can find the inverse functions of this form, then at this point maybe 2 comma minus 3. This is where I want the density function. To find the corresponding x and y, I have to plug it in here and I will get some value 7 plus 7 comma minus 10 or something of x comma y. And that is what I have to put it in fx of x comma y. That is why we are finding this one. Because these, okay, this one. Then f uv of u comma v is equal to fx y at x and y. But what x and y? They are, that x and y is obtained from this one. For this uv, if you substitute and then get whatever x and y, that is what I have to put. That is phi of u comma v and psi of u comma v. For this is where I want to find what x and y lead to this. This or the one. Okay. See, this is a function. But I have to substitute the actual numbers evaluated at u and v. Of course, I have to use the same symbol for variable as well as a particular value. At a given value, wherever you want to find, you find these inverse functions and evaluate these at these points. Minus 2, minus 3 means minus 2, minus 3 something you have to put and find these values. So that is how densities are related. But the Jacobian has to be put j. We will put it as j. And it has to be positive, so I will put mod j. And what is this one? See, somewhere here du dv will come, here dx dy will come. But the actual one is, this is follows from calculus only. I am not going to do that. So that is how it is related is, here it has to be x on the top, and the numerator has to be x, y, and the denominator has to be u, v. Okay. So what is it actually? So this one, tau phi by tau u. So this is the Jacobian that you have to multiply it here to get this. Okay, if you are confused, this is okay. I will finish one more thing and then I will tell you. If there is a confusion, how to arrive at the correct Jacobian. Like that you have to do. What we are basically doing is f u v u comma v du dv is equal to f x y sum x comma y dx dy. That is how they are related. To get this amount, the dx dy by du dv. In proper this one, this is how it has to be whole good. Suppose for that you have to find phi, psi and so on. Of course you have to find out in order to plug in the right value and then differentiate it with respect to u, v and so on. Alternatively, you can define another factor also. We will call it a Jacobian tilde. That is actually using the original function tau g of x comma y by tau x. You can define this because g and x are already given to you. So differentiating it easily you can get it. But the only thing is that inverse difference mapping you have to find only to find what uv, what xy you have to substitute here. Once you have to find out this one, it is known that j is equal to 1 over j tilde. Again all these follows from calculus. They are inverse. Why? Because that is something like dx dy by du dv. Here it will be du dv by dx dy. That is why they are related. So there is another way of writing this one. F u v of u comma v is equal to f x y of If I want, I can put, sometimes I will put G inverse of u comma v, but in a single variable it is okay to put G inverse. But if you have two variables, I am not very comfortable in writing G. There is no, because together it is dependent upon both. If you want, you can put also H inverse of u comma v. By that, what we mean is, this will give me x and this will give me y. For these two UVs, okay, into j tilde minus 1. Okay. This is the same as that. Instead of phi, I am writing as j inverse h inverse. That's the only thing. There is no other difference. If you can understand what this is. So this is how we have to generally find it. What we will do is we will take some examples and then go through it. First, we will start off with linear functions, which are so easy to understand what happens. Okay? So, these are x and y are two random variables. We are now not even going to talk about what is their density functions and all this. It can be any random variable, Gaussian or any random variable, exponential or any random variable. But u and v are, and they are not necessarily independent. So what is given is only the joint density function of x and y. We are given two dependent random variables u and v related to x and y using this formula. So what we here we mean is g of x comma y is 3x plus 5y. I will put small letters. This is ordinary by the way. And h of x comma y is x plus 2y. So this is what is given. So we will try to follow this step. So what first I am looking for is, I am looking for x is equal to some phi of u comma v and y is equal to some psi of u comma v. First I have to find out given these two things. So I have to just solve for x and y in terms of u and v. What is this? Is what is u? This is what is v. So what I will do is I have to solve it. I will multiply by 3 this one. So I have 3x plus 5y is equal to u. Here I multiply it by 3x plus 6y is equal to 3v. So I will subtract this from this one. So 6x minus 5y is y. That is equal to 3v minus u. This is one thing. So just substitute it here. 3x plus 5 times 3v minus u is equal to u. So this is 6u. So I am looking for x. 3x is equal to, this is 6u minus 15v, and therefore x is equal to, so multiplied divided by 3, 2u minus 5v. This is one thing. And another thing is y is equal to this one. Again, it's good that you order it always, u v followed by, this is of this form, I will put it a minus u plus 3. So this is u coefficient, v coefficient and so on. Now what I am first having got this inverse formula, then the next one is the Jacobian. You will find j. Okay, that is it. This one. So you can find this is what is phi of u comma v. This is what is psi of u comma v. So we can find out tau phi by tau u and everything. These are very simple now. Individually we don't need to find. So J is equal to if you look at this one, this will be just this coefficient only. Okay, this will be 2, this will be minus 5, this will be minus 1, this will be 3. So that is equal to 6 minus half plus 5 is equal to 1. So the Jacobian is just 1. So what it means is f u v f u comma v is equal to f x y of what x and y I have to put for these two u v. I have to put the x and y, which is this one, which is this one, 2u minus 5v comma minus u plus 3 into 1. That's it. Okay. So what you have to do is, if you are asked what is f of u comma v, for this u v, you substitute here and find x and y, and that evaluate f x y in that value, multiply it with Jacobian, you will get the answer. So what you have to simply do. Well, to give an example, to dwell little bit more into this one, suppose now so far the density function is not even given to you. It's an arbitrary density function. Suppose a particular density function is given. If you are told that x and y are IID standard normal random variables. What does it mean? X is n of 0, 1, y is n of 0, 1, and also they are independent. So you can directly write f x y of x comma y will be of the form f x of x into f y of y, because they are independent. For each one you know the distribution f x of x is equal to 1 over root of 2 pi into 1 into e power minus half into x minus 0 the whole square by 1 square, which is x square. This is the standard normal density function. Look, sigma squared is 1. Here also there will be a sigma squared which will be 1. X minus 0, so I am leaving it. So this is given. So if you multiply 2 of this one, you will get 1 over root 2 pi will become 2 pi, and e power of here x squared, this is fx of x and fy of y are true. This will be x squared and w y squared, and both are in the top of e power something. So you can add the exponent. It will be e power of minus of x squared plus y squared by 2. Okay. So this will be the joint density function of standard normal Gaussian random variable, which also incidentally will tell you that if you have n Gaussian random variables, standard normal, which are all independent, then it will be easily you can write f x y, okay, so whatever it is, it will always be of the form of n such things. Let us say n such things. It will be always 2 pi to the power of n by 2. Each one will contribute root 2 pi. There will be n of them. All of them you can multiply. Fx of x, fy of y, z of z, and everything you can multiply. So it is root 2 pi power n, that is 2 pi power n by 2. And here you will have minus of 1 by 2 you will have. Because these are all mean 0, this one you will have here only x1 square plus x2 square plus xn square. This is the form of a joint normal distribution, joint where each one is independent, they are all standard normal. That aside. Now what are we trying to do? Suppose x and y as this one. Now for this particular f u v, what we have to do is the same as of u comma v will be f x y evaluated at 2u minus 5v comma minus u plus 3v into what? If u and v are related to this one, this is the formula we have obtained. If x and y are actually IID standard normal distribution, this will be the x. So for this particular joint PDF of x and y, what will be the joint PDF of u v? So you substitute it in this form, in this place, 1 over 2 pi into e power minus half into 2u minus 5v the whole square plus minus u plus 3v the whole square. This is how you will get. This will be the joint PDF of u comma v. The point why I just not substitution is so easy. The point what I wanted to mention is x and y are independent, and that is why their joint PDF factorizes into product of individual PDF. What it means is, here you can write it as 1 over root of 2 pi e power minus x squared by 2 into 1 over root of 2 pi e power minus y squared by 2. They are separately x and y terms can be separated out. But here you can't do it. You will get u square term, v square term, uv terms will come. That you cannot separate it out. You cannot write it as a product of a function of u and a product of function of v. Which means that u and v are correlated, whereas x and y are uncorrelated. They are independent means they are definitely uncorrelated. But here they are correlated. This mixes the random variables. Okay, and therefore they are correlated. So that is something which I have note. You will again look at a case, no, not just linear. You will take something, two functions of two random variables, but that functional nature is very useful in communication engineering. Okay, it is quite often encountered. Let x is n01, y is n01, and so there are two Gaussian random variables, and we are interested in two functions u, which is square root of x squared plus y squared, and v is tan inverse of y by x. Okay. So what it means is, as you could easily understand, if x and y take these values, they are any, you can view it as a random vector. Okay. Mean 0, this one means if the vector can be of this way. X alone, if you look at the x can be this way or this way and so on, and the length can be variable, but the standard deviation is given by this. That kind of a random vector is here. If you take a realization of this x, it will be a random vector along this one. If you take a realization of y, it will be another random vector like this one. Of course, this is not very probable, this will be. And then, if you look at the resultant one, okay, this vector, because x and y are related, they are the x and y component of some one, and this one is the magnitude. that is root of x square plus y square. And this angle theta is tan inverse of y by x. So you may have two Gaussian random variables which are orthogonal, which are being added up. Okay, they are, and the resultant value is what you look at it as a signal, and that can be viewed as having a magnitude with some phase. That is what this u and v signify. So now how do we do it? Now this is g of x comma y is square root of x square plus y square. H of x comma y is tan inverse of y by x. These are the two functions that are given. Now we are looking for first an inverse function, phi of u comma v and psi of u comma v. This is u. This is v. Did I mention? Yeah, that's what we are looking for. So that is what we are looking for. What x and y will give to this one? How do we, given x comma y, given u comma v, what x and y will lead to this? It is easy to figure out, okay? So this will be, that is, we have to write x equal to, this is x. U is the magnitude, u sin v, and this will be, this is what is y, that is equal to u cos v. Huh? Okay. Y will be, yeah, u cos v. Because this comes here. Sorry. U, this is by why? Because if you substitute this one, you will see that u squared cos squared v plus u squared sin squared v, you take u squared and square root you come, it gets u. And here if you substitute, u goes away, it is sin v by cos v, that is equal to tan inverse of tan v. That is how we get a v. So they are just inverse functions. So we have immediately found out the functions. Now next is the Jacobian. Tau phi of tau u, tau phi of tau v. That you have to find. So u, if I will do it, I will get cos v. Here v I have to do. So cos v differentiation minus sin v. So minus u sin v. And this one I have to differentiate with respect to u and v. So u means sin v and v means it is u cos v. So if you look at this one, the Jacobian, so u into cos squared v minus of minus plus u into sin squared v, that is equal to u. So the Jacobian is just u itself. Then now what we have to do? Yeah, let's say x is n01, I have mentioned it. So, sorry, is known to be so I want to put for x in place of x, where is it? X. I have to put u cos v. So u squared cos squared v plus u squared sin squared v by 2 into the Jacobian of transformation u. Right, this is how we will this one. So translate. So what I will get is 1 over 2 pi. I will keep this separately and then put u e power of minus u squared by 2. So this is what uv of u comma v. Then this one, first of all, are uv uncorrelated? Is it possible to separate out a function of u itself, a function of v? Okay. See here, v doesn't figure out at all. So anything you can take it as function of v. One also you can take, or something else, anything else. But there is a function of u. These two are functions of v. So this is fu of u. I can conveniently take this as the function of v. If I take this one, now I can tell that u and v are uncorrelated. They are independent, number one. And this one, what does it tell you? What is v? V is the angle. V is the, theta I have put, theta is what we are calling it as v. I should have put, okay, v for understanding I have put. So v is the angle. So if you have two Gaussian random variables, one is the x component, another is the y component, both are independent, standard normal Gaussian random variables. The resultant vector, this is a random vector. It can be, this random vector can take any values, like this can take any value. I am looking at the independent one. That resultant can have an angle which can be anywhere oriented like this one. So the theta can lie between 0 to 2 pi uniformly. That is why this is a uniform distribution between minus pi to plus pi. So I will put v is a random variable which is uniform between minus pi to plus pi. Then I will get 1 over 2 pi as the one. So this is what I can, that's how I can interpret, because angle can be anything, because two independent random variables can take any, the random vector can have any orientation, so theta has to be uniform. But the magnitude is of this one. So this is a kind of a function which is useful, and this is called as the Rayleigh distribution. So you will later, have you had any course on communication systems so far? So in communication theory and all, we will often model a channel as a Rayleigh distributed channel. Okay, so this Rayleigh distribution comes from that fact. What is the time now?
12:50. 1 over.
Okay, so we'll start now.